And now, welcome to the main stage, Spring Developer Advocate Josh Long. Give him a round of applause. Woo! Woo! It's awesome. I'm here. I did it. I self-introduced. That's probably not right. Hi everybody. Welcome. Good to see you. I'm so you wouldn't believe the year I've had since we last spoke. It has been a year. It has been quite the year indeed. But I'm so happy to be in front of you today. How are you doing? Good? Yeah. Okay. Great. I appreciate that you're all here. Look, we've got some. They're gonna cut the feed right at very strictly. I was told we got to be done out of here at a very specific time. So let's get underway, my friends. We got a lot to talk about and very little time in which to do it. My name is Josh Long. I work on the Spring team. I'm a Spring developer advocate at Kotlin, a Google developer expert, a Java champion, and most embarrassingly, a YouTuber. And don't judge, okay? I mean, not too much. And I've got email. If you have questions, I'm out there on the emails. Who's using email? Anybody use email? Yeah, me either. Okay, good. X, Twitter, the bird site. That's whatever. And yeah, just so find me there. Find me online. We're not gonna have enough time to cover everything today. And I want to preface that right now. I want to just say it right now because tomorrow I'll be doing a talk with my friend, the one, the only, the amazing, the lead of Spring Security, the amazing Rob Winch. We'll be talking about all sorts of stuff about going passwordless, right? So check out that talk. That's gonna be a lot of fun. And then I'm gonna be doing another talk tomorrow with it should be titled Two Doctors and Adult, right? It'll be Dr. Rod Johnson, the creator of Spring, and Dr. Mark Pollock, the creator of Spring AI. They'll both be there, and then I'll be there to serve coffee and that kind of stuff. And that'll be tomorrow as well. So find those talks. Those are gonna be good. This is, I mean, you can't leave. You're stuck, okay? So let's just get underway. My friends, look, you probably saw the keynote. I really do have a terrible dog, right? I really do want to think about how would I build that service to support that process, right? And in the keynote we talked about building an adoption service to support rehousing a dog, and I talked to you about this amazing dog about which I learned during the pandemic, right? And the reason I show you this is because we didn't get a chance to really enjoy this, but there's this woman who's looking for a new home for her dog named Prancer. Prancer, oh, this dog is everything. So, the dog, she described this dog as, here we go. Yes, she said this dog is a neurotic, man-hating, animal-hating, children-hating dog that looks like Gremlins with an S. I don't know why I guess it's so ugly that it looks like more than one gremlin, which is incredible. And the dog is really cute, in that way. And so Prancer, again, the idea, the same domain, okay? We're gonna stick with that. And I told you about my dog, right? This dog reminds me of my dog. I love dogs. I just don't love my dog, okay? My dog is a bad dog, very bad. His name is Peanut. And there he is. He's cute on the outside, right? Evil on the inside. Pure malice. Not a good dog. But very cute. So we keep him because we love him, and all dogs deserve a home. And so again, same idea. I want to build something to kind of take advantage of this theme of a dog adoption service today. And we're going to do that today, as always, by going to my second favorite place on the internet. And my friends, one of the key things about this moment in time, I think we just have an incredible opportunity right now. There's never been a better time to be a Java and Spring developer. Never, ever. It's just an incredible confluence of things that have put us in this position. So we're gonna build an application today. I'm gonna call this Bootiful and Service. And again, I'm really good with names. That's why we're gonna call it Service. We have some dependencies we need to add: the GraalVM native image support, the web support, the Spring Data JDBC support, the OpenAI support, the PG vector support. We could use Docker Compose, right? If you use Docker Compose support, you get a nice Docker Compose file, which has all the bits that you'll need, and Spring Boot will automatically start up the program with those Docker containers running for you. But I've already got, as I did yesterday, the same Docker instance running. We also want Spring Modulith, and we want, what else? Do we need anything else? Let me think. GraalVM, Web, JDBC, OpenAI, Vector, Modulith. It's probably fine. I'm not even sure. Do we get the PG vector? Let's just assume that it is. Then, my friends, we have a question about what version of Java we want to use. Friends, there are 3 checkboxes here, 3 radio boxes that you could select, but of these 3, only 2 are viable choices, okay? And so you've got Java 17, 21, and 22. Notice that we don't have any Java 8 here. There's a reason for that. It's not a subtle clue either, by the way. It shouldn't be hard. No, there should not be Java 8 in your life, you know? Java 8 ain't great. Just get rid of it. Move on. And in fact, if you're going to move on, don't stop at 17, I guess what I'm trying to say. There is no circumstance in which you should be using Java 17, right? Java 21 and later are technically superior in every way. They're faster, more robust, more syntax-rich, more performant, more operations-friendly. They're also morally superior. You won't like the look of sadness and shame in your children's eyes when they see that you're using Java 17 in production. Don't do this. Be the change you want to see in the world. Do the right thing. Use at least Java 21 and later. And Java 21 is, the reason I'm okay with this, although I can use Java 22, is that it's an amazing release, as we'll talk about in a second. There's 2 big things that come in Java 21. One, data-oriented programming, and the other, virtual threads. That taken together are, I mean, this is the single most important upgrade, arguably since Java 1. It's an incredible release. I could not be more hyped about Java 21. I still am. I mean, I'm just excited, right? So we're going to use Java 21. And let's open this up in our IDE. And, same as before, we have the Docker container already running. So I'll specify the credentials here. Let me just make that bigger, okay? Spring, data source, JDBC, :PostgreSQL, localhost, my database, database. And then we have the username, my user. And then the password, right? Secret. Okay, so that allows us to connect. Let's just confirm that works. Click on the little button, click on the test connection, hit apply, hit OK, go check it out over here. And just like before, we have our dog table, okay? And there is our dog Prancer. Again, we want to get to a point where we can adopt this dog. So let's go ahead and build that just like before, right? We're going to go ahead and build a service to support adopting the dog. And we'll say adoptions. And friends, in order to work with this data, obviously I'll be using Spring Data JDBC. And so I want to create a adoptions controller, okay? And this is just going to be a simple HTTP endpoint, and I'm going to be working with Spring Data JDBC, so I'll describe my data in terms of, IntelliJ. Why? Okay, string name, string description. All right, very good. Very good. There's my type. I love records. How many of you are using Java records? I love records. I love them. I love them. Love them so much. Love them so much, right? This is an amazing thing, okay? We've got a dog repository. And extend list of CRUD repository manage type dot. This new IntelliJ release is testing my patience. Here we go. Okay, so we got a repository, we got our entity. Great. Isn't this nice, by the way? This is just an amazing thing, these records. This is not just a better Lombok, though. That's the important thing here, right? This is actually part of a number of features in Java 21 and later called data-oriented programming, right? And these features include sealed types, smart switch expressions, records, and pattern matching, right? And the core conceit behind this new paradigm, these new things, is that historically Java has been dominant. It survives and it thrives in the world of large monolithic code bases, where you have new things being added to the system by creating new specialized hierarchies of types, right? Well, now, increasingly, the way we communicate a new feature in the system, or that we want to send a new message into the system, is via data, right? And that data could be stringly typed network data coming in from Kafka, or RabbitMQ, or GraphQL, or REST, or whatever. But it's data. It's not specialized types in deeply seated hierarchies in a monolith. It's small services sending messages around, right? And so the language has to be really elegant at that, right? And it was fine before, with thanks to the help of things like Lombok and the like, but really, we could do better. And so that's what this is. These things taken together offer us a new paradigm, a new ability to work with data as a first-class thing, to pass it around, to match on it in pattern matching. to do smart switch expressions, etc. These all come together to support this new idea called data-oriented programming. And Brian Getz, Java language architect Brian Getz, talks about this in an InfoQ article from 2022. So, not now, surely not now, but soon, maybe you can go read that. It's really, really quite an eye-opening thing, okay? So even though I'm using this here, don't sleep on the opportunities that this implies. That's just the beginning, the very surface of the water, you know? Okay, so, we've got our controller. We want to, you know, adopt a dog, right? Let's do the hard part here. Okay, add that controller, and I'll create an endpoint here. Okay, dogs, and then the dog ID, and then adoptions. Yeah? So void adopt. And okay, we want the path variable, integer, dog ID. We want the request body, right? Request body, map of string name, okay? There we go. There's our contract. So the person that's going to be adopting the dog will get from here. So let's see, adopter, whatever, and adopter.get name, okay? And now we can say this.dogrepository.find by ID, dog ID. If the dog is present, then we want to create a new dog and write it to the database. So new dog, okay, dog.id, dog.description, right? And those are the basic fields, but we want to update its owner field as well. So let's go ahead and add that to our type here. We'll call it owner, string owner, voila. And we'll pass that in. So it'll be name, yeah? So we're updating this, and now we're going to save that back to the database. We'll say dogrepository.save. All right, good. So there's that. There's our updated controller. And of course, we want to enumerate all the dogs. We can just do that here. Dogs, collection, dogs. Okay, not a big deal. Return this.dogrepository.find all. Holy moly. Okay, here we go. Maybe that's a little too big. Let's try that again. So it's up and running. Localhost 8080, dogs, circular path. Oh, okay. Aha. Response body or bust. Okay. Okay, there we go. It worked. Of course it worked. It was a demo. It was always going to work. There was no question about this. Okay, so moving on. Now we have the ability to get the data. Let's see if we can update it, right? So curl -d. Okay, -d, quote, double quote, name, JLong, hey, back, X post, H, content hyphen type, application, JSON, HTTP, localhost, 8080, dogs, and remember, 45 is the ID, adoptions, okay? There we go. If I go here now, and refresh this page, oh, still not updated. What happened there? Did it, dogs, dog ID, adoptions. Surely that ran. Oh, I didn't say, I saved the wrong one, friends. Restart. Okay. Okay. There we go. We've successfully adopted our dog. Now, this is a very simple example, but, you know, in this example, I have one service that's responsible for its own data, and it's managing that data within the aggregate of the dog adoption module, okay? It's very likely I'm going to want to involve other parts of the system, right? And so you saw Cora yesterday very elegantly talk about the application module listener. I can actually, you know, I can use messaging to decompose this system. And by the way, this brings us to a great blog by Martin Fowler, that asks the question, what do you mean by event-driven? This blog is from 2017, before the COVID pandemic, so BC. And this blog talks about event notifications. This is a simple act of using an event to tell another system that something has changed, the details of which are sort of immaterial. They're not communicated in the message itself. This is a very nice way to, you know, like, maybe you have a cached view of something, and if something changes anywhere in the data, you need to reload all the data. So it doesn't matter if you know which record changed, you're going to reload it all anyway. And if that's the case, then there's no need to communicate the details of what has changed. You can just reload the data, right? So you can use event notifications as sort of like a heartbeat, a pulse. It tells you something has changed and you should know either how to get the details of that change or just what to do with just that notification, right? That's a very lightweight way to communicate events across the system. However, sometimes you want to know the details of what has changed. So then you get event-carried state transfer, wherein you communicate from one module to another, from one system or service to another, the state changes, the delta. This is the new customer that was added to our database. This is the new product that was placed in a cart or whatever, okay? And here, you're actually starting to get into log sets, change sets, right? Each message is now a change set for the state of my system. And if you appreciate that, and if you appreciate that all changes in the system are now, they're represented by messages in the broker somewhere, in the queue, right? Well, then something else wonderful happens, which is that message store, if you have access to all the messages, is now a auditable, replayable history of the state of your system. That's called event sourcing. And it's the insight that I can replay all those messages that I've ever received in the order that I received them and arrive at the same state. So imagine I've got a Redis cache for over here, and I've got an Elasticsearch search index over there to support fast reads over there and full text search over there. If I, RMRF both of those and reset them, and then replay all the messages, I should arrive at exactly the same cache and the same full text search, right? And that's a very powerful thing to think about, right? Because your system, more often than not, is not just a single database. It's not just a single domain or a single module, it's several. And they have their own data sources for their own use cases, but the messages tell the truth. And if you understand that your system is no longer just one data store, and you might have other views of the data optimized for particular kinds of reads, well, that insight is called CQRS. Command Query Responsibility Segregation. It's this insight that I'm writing to a system is different from the way I might read from a system, okay? So messaging is super powerful, and we're only touching on just a very bare minimum possibilities here. But, this is just the beginning, right? So, okay, I want to use messaging in Spring. You might not know, but we've had an event bus in Spring since nigh the very beginning, right? This is called the Application Event Publisher. It's been in since 1.0-ish, right? If I download this code here. Okay, there we go, 1.1.1. And by the by, hopefully you all saw this, right? SpringOne.io, History of Spring. Did you all see this last year? This is awesome. This is a video game you can go to. Play the home game if you like. And it's, the history of Spring. You can kind of, Rod Johnson publishes the book addressing J2E complexities. By the way, that's Dr. Rod Johnson. He'll be in the talk tomorrow. Come meet him. He's great. He's, he floats and has white glowing eyes, but he's normal, just relatable like all the rest of us. Okay, so you can play Rod Johnson, Jürgen Holler, Jan Karaf, start the open source project. Spring Framework 4, 1.0 rather, is released in 2004, so 20 years since GA, right? Now we're going through here. Spring Boot, 2014, 10 years ago, right, since GA, okay? Now we got Spring Batch, we got Spring Integration 4.0. We're going up into the clouds. Hopefully that's not too subtle. We're in the cloud. Spring Cloud 1.0 release, providing tools. Spring Cloud Task, Spring Cloud Stream, Spring Cloud Dataflow, going back down. Water, maritime themes, again, Kubernetes, very subtle. Spring Cloud Dataflow 2016, keep going. Spring Cloud Skipper, Spring Cloud Gateway for Kubernetes. And this gets us more or less to the modern era, 2022, wherein we get the Spring Boot 3.x and Spring Framework 6 generations. And in this video game, we always win. Everybody wins all the time. Okay, so anyway, back to this. We've got this event publisher, and what I want to do is I want to publish an event, and I cut out the middle bean here. I might have had a service that I then asked to publish or to save this state, but whatever. So I'm gonna publish an event now, communicating this change, right? So this .publish event, and here, my friends, I get to my first public type. Now, I do my level-headed best to avoid creating public types, right? Try it at home. Go home and see if you can remove the word public. It shouldn't break a lot of things. And if it does, you're doing it wrong, right? This is one of those anti-patterns I see borrowed or heavily lifted from the likes of the Ruby and Rails community, where you have models, asterisk, services, asterisk, controllers, asterisk. If you're doing this, please don't, try again. Why would we cargo cult that from the Rails community? There's a lot of things you could cargo cult from that community that are pretty neat, like their testing discipline. But it's a terrible way to build software. Don't do that. And if you're doing it, you try undoing it. You've got yourself a mess. Remember, every time you do that, you have to make everything public, because if I've got a class called controller, my controller in another package called controllers, in order for that controller to inject a service, which is in the service package, that service needs to be public. Public isn't the default in Java. The intent here was that these things would be modular, insulator, right? You'd have privacy, access control. You have to go out of your way to add the word public, right? It's there. It should be used sparingly. So try removing it, see what happens. Or better yet, try not adding it in the first place. And eventually you'll end up at this sort of more modular architecture, right? So we've got a record, and it's going to be an integer dog ID. I'm going to publish this message. That's the only thing that's public in my code so far, is this thing, right? Dog adopted event, passing in the dog ID. So ndog.id, okay? And of course, I might have another service. Let's suppose it's another module here. Create a new package called vet, and maybe there I'll have a vet service, and this is just a net service at transactional. And I want to listen for that event. Well, of course, I can use the @event listener, right? Dog adopted event. This is a annotation version of the interface that was in Spring since the very beginning, right? So thread.sleep. Oh no, useless. Okay. Okay. System out. Got an event. Dog adopted event. And take that out there, okay, after. And I'm gonna make it 10 seconds, okay? So let's go ahead and run that. Okay, so now I go here, publish this event again, and look, I hit enter seconds ago, but it still hasn't returned. So the default behavior when you use Spring's messaging dispatch is it's synchronous, and which is kind of convenient if you want things in other modules to be in the same overarching transaction. But I don't. That's the whole point. I want to decouple this code from the transactional boundary of that thing, right? But I don't want to lose the message either, right? So there's this really nice capability in Spring Modulith to allow me to get the best of all worlds, right? And I can say application module listener. This is basically @async plus @event listener plus transactional listener, right? I think it's transactional listener or event listener. So all these things combined, you get this annotation. This pairs like a fine red wine with some other features here. To use Modulith to republish outstanding events on restart. To support that, though, you need some middleware. You need to store some data somewhere. So I'm going to tell it to initialize a schema here. Okay, so now make the same request, instant return, right? But if I pull the plug on the machine right now, I still haven't finished my 10 seconds in the other module, I might lose my message, right? Well, no, I've got here a table called event publications. And it's got the publication date, the payload, and the completion date. If I had pulled the plug before the method was finished, this completion date would be null. Case in point, right? Refresh, it's null. 10 seconds later, it'll be not null. And if I pull the plug on it right now, refresh, it's still null, right? Now refresh and restart the application. It's going to replay that message before got an event. So if I missed a message before, for whatever reason, if the service went down or there was an outage or the network died or whatever, it'll replay the event and make sure it gets redelivered and reprocessed on restart, right? So I get the best of both worlds. I'm no longer bound to it, but I also don't lose it, right? Nice. So I love Spring Modulith, and I've been talking about modularity and module this and module that. What does it mean? Well, it turns out it's actually backed by a set of tests that are based on ArchUnit, right? ArchUnit is a testing framework for enforcing constraints on your architecture. And you can kind of see this in action by creating a simple test. Okay, so we go here, application modules dot of and service application dot class dot verify, right? And even better, you can do new documenter. Let me get that. There we go. Okay. Go here, application modules dot write documentation. So if I run this test now, let me see, Control-Alt-R, this test here, it's going to run the constraints. It'll look at that and make sure that everything is to plan. It'll actually verify that everything is working, and it knows, by the way, about the structure. If you actually print this out, it knows about the structure of your program. So system out application modules dot toString. Okay. All right, let's see. There you go. So it actually knows about all this stuff. There you go, right? Logical adoptions, vet, etc. And it's also printing this stuff out here on the class path. Generated source, Spring modular docs. You get this nice architecture diagram based on the knowledge it has of your system. So components, there you go. It knows about how these things are tied together. So it's living, breathing architecture. All right, so good. We've got a modular system. Obviously, we want to support finding our buddy Prancer. So again, we'll build an assistant, okay? I'm gonna go back here. I'll say dog adoption assistant at configuration. Same as before, we want to have a chat client builder build, okay? And we want to build a bean that will be able to answer questions, right? To find this dog, to answer questions about it, to make it easy to make decisions about which dog. Because so far, we've only been able to adopt a dog given that we know the ID. But what if we don't? We're going to have somebody with whom we can talk. So let's build a simple assistant, a dog adoption assistant, okay? And you can imagine this being an HTTP endpoint or something. So obviously, we're going to build a call, pass in the user, do you have any neurotic dogs? Call content, and that'll be a string, var reply equals. Print this out, reply. Okay, good. All right, so if we run this, what are we expecting to happen? Well, I'm going to be using OpenAI. I've got that Spring AI project on the class path. For more on this, by the way, did I mention Dr. Johnson and Dr. Pollock and I will be doing a talk tomorrow, so, there's that. I'm going to use OpenAI. I've made the decision on which binding to use, but it is Spring, so you can just swap out the starter and everything will be fine. You need to specify an API key. As I said yesterday, I've already done that as an environment variable, so there's this. You also need to specify what model you want to use, right? So I'm going to use ChatGPT 4.0, and I'm going to ask it this question and get the response. Let's just print it out and see what's what. Oh, what happened here? Spring main allow bean. It's the okay runner. All right. Okay, so that still didn't work. Let me see. Control-Alt-R. This one. Okay, I'm going to ask it a very nonsensical question. It says I don't have any pets. Of course it doesn't. Our AI doesn't know about our dogs, and it doesn't know any of their characteristics. So let's integrate that by, simple RAG pipeline, right? Vector store and dog repository. And we'll do that again. So dog repository dot find all dot for each dog var document, new document, okay, ID, name, and description, formatted, and it's going to be dog.id, dog.name, dog.description. So what I'm doing is I'm writing this out into a document, and I'm going to then write that into my vector store, okay? So what is the issue with this? Wrong document, surely. I think something's wrong with the new IntelliJ release. I honestly, I don't understand. I've never wanted to use this document. Not once. Not in my life. I mean, not just recently, ever in my life. And yet here we are. It thinks I did. Okay, so we've got this document. Let's write that out to the vector store. So we'll say vector store.add list.of document. Okay? And what that's going to do is it's going to put it in a vector store, which supports similarity searches. There are lots of different vector stores out there. Spring AI supports many, but you can even use an in-memory one. It's not hard to do, right? This is in the Spring framework, in Spring AI code base. It's not even a lot of code. It's like a few hundred lines of code. So if you're wondering why all your favorite AI technologies have vector store support, it's because it's easy to add, right? It's just simple cosine similarity. This is actually a very nice thing. And the reason we use this is because this vector store can act as a staging area wherein we can sort of winnow down the results, narrow them down, and then send the results that still are useful off to the AI, to the model, to do analysis, okay? So I'm going to write these out. Let's see here. Here we go. In order for that to work, of course, Spring AI is going to initialize a vector store. So PG vector, vector store initialize schema equals true. Let's go ahead and run this. And then once we do that, we want the model to know about our vector store and to be able to get data out of it, right? So let me actually put this up here. And this is a part and parcel of RAG, Retrieval Augmented Generation, right? So I go here. Good. And finally, I'll specify a question answer. I'll say default advisor, new question answer advisor, passing in the vector store and the search results. All right, good. Okay, let's just try running that and see what we get, huh? It's thinking. It's thinking. Maybe? Oh, it's initializing the data, surely. So you can see it's writing out the records. There you go, 18 records. And we got a response. Yes, we do have a neurotic dog. Prancer is described as a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin, singular, right? So we've now integrated our AI with our data and our APIs. This is actually pretty powerful. Now, it's not all that hard to do, but we can do it, and all we had to do is write this one line of code. So let me now disable some of the initialization that's happening on startup, right? It's now time to turn towards making this more production worthy. So first things first, I want to initialize a schema. No, thank you. I've already done that. I don't want to initialize a PG vector schema anymore either, right? And I am also not going to initialize the vector store each time. So now if we restart this with all those things disabled and only the outstanding call there, what do we get? Okay, so we got the result, 1 second, and we got a response. Okay, it's time to go to production. And I think here, friends, there's a lot of things to think about. First of all, I've been making those calls to OpenAI. It's not particularly slow, but as these things go, it's also a long time, right? It took several seconds to get a response in sometimes, right? And we got to think about what the implications are for our service as we build it like that. When we make that network request, we're getting an input stream, we're reading the bytes, and we're just doing input stream.read. This is just sat there on a thread somewhere, right? And Tomcat has a thread pool, so we're doing the request in a thread in the Tomcat thread pool. Well, Tomcat only has so many threads available to it. So the last thing we want to do is monopolize those threads, waiting for these very long, lengthy, sometimes outputs from our AI, which gets us to another question. How do we do that? And of course, there are some answers here. You could use non-blocking I/O, right? But we're not. We are using blocking I/O. Spring AI, the drivers for all these different vector stores and models and all that, is using regular Java I/O input stream and output stream. So unless you want to rewrite all that, that's not an option. So this gets us to an amazing feature in Java 21 called virtual threads. How many of you have heard about it? Okay, virtual threads are, again, the magic of the Java ecosystem. I haven't seen a single thing that does something as elegantly as they did in this release, right? I'm a Kotlin Google developer expert. I love Kotlin. That said, they kind of missed the boat there, you know? We have suspend functions in Kotlin. Other languages, I'm using the term charitably, other languages like PHP, I don't even think they have it. No, other languages like JavaScript, they have async await, right? This is actually the very first time, I think, in recorded history where we in the Java community can say, hey, no, JavaScript, Python, C#, you should do it like us. It's the very first time. Enjoy this moment. It won't last, but it's the very first time. They did an amazing thing here. If you want non-blocking I/O, there's no more concise way to do it than to use Go. If you want the second most concise way to do it, then use Java. And the difference is Go was built from the first day, ground up, with non-blocking I/O in mind. There is no blocking I/O. Everything is non-blocking by default. Whereas Java had to saddle on this feature and keep backwards compatibility in mind, right? So virtual threads are an amazing result. And let's take a simple example. I mean, if you want to enable that in your application, just do virtual threads enabled equals true. And we'll automatically switch on virtual threads for you in your example. No, but I want to show you kind of an example to kind of demonstrate the real value here. Let's build one more endpoint, okay? Let me just go over here. And I'm going to steal an example. I'm stealing this shamelessly from Cora, my colleague, Cora Eberklade, right? It's amazing demo controller, okay? She's brilliant. And she has this great demo she did at SpringOne last year, which I just think about it all the time, because it just shows, without too much fanfare, how amazing virtual threads are in the Spring ecosystem. So let's say I want to make a call to HTTP bin, right? Var, so we want to say var URL equals HTTPS, httpbin.org delay, and then I'm going to put 4. 4 is the number of seconds I want to wait. So if you bring up this URL in your browser right now, it won't return until 4 seconds later. It's artificially prolonging the time it takes to get a response. So I'm going to make a request here. Private final REST client. Okay. Add that, and I'll say REST client.builder. REST, and I'll say this.build. Whoa. Builder, please. Good. So now I've got a REST client, and I'm going to say this.client.get.uri URL. Okay. .retrieve. .body. Just going to make it a string, and I'm just going to return that response. Surely, easy, right? We know what's happening here. I want to limit artificially, because again, as Sebastian just alluded to before, our laptop. This is also an inversion. When I first started working in software 20 plus years ago, it was my dream to be able to log into a production server before we turned it on in production and play Doom, right? Those things were awesome. They had all the capabilities, you know? They were beefy machines. I enjoyed those machines. I wish I could have had that kind of power at my desktop. Now it's the other way around. In the cloud, all your machines are like these puny commodity nodes, whereas this thing, I can run Slack and Chrome at the same time. Science said it couldn't be done, but here we are. It's an amazing, amazing time. So I've got this incredible machine. I need to pare it down a little bit to simulate what we might get in a more realistic production context. So Tomcat, threads, max, not 200, 10, okay? Okay, so there we go. We're gonna limit that a little bit. I've got virtual threads enabled, but I'm gonna disable it here for a second. So it's not gonna be great. Okay, let's go ahead and restart this. Yeah, let me try that first. Let's just make sure. We should see if I make one request to /delay that we get a 4-second delay, right? So curl HTTP localhost 8080 /delay. This is awkward. Okay, there we go. 4 seconds, okay? So it's working. So now let's drive some traffic. Hey, -C, this is a -N and -C. So let's say 20 concurrently, but 60 total requests. Okay? This is like a load, it's like AB, Apache Bench, or whatever. I'm gonna drive 60 requests total, but as many as 20 at the same time. Mind you, I just limited it to 10. So somebody's gonna have to share, and threads, you know how they are, they don't like to share. So here we go. We'll just wait. Doop-a-doop-a-doo. This is why I keep coffee on this stage. Come on. Whoa, I didn't know the user agent was Java. That's pretty great. Look at that, it's even got the version and everything. Yeah, you can see what's going on here. 60 times 4 seconds with only 10 threads. Okay, good. So there's the bad results, okay? Let's take this. Sublime, open that up. Here we go. So that's the, without. And you can see that we got 1.9 requests per second achieved, because there's no sharing here, right? There's no, we're sitting there on the thread waiting for the response, and nobody else can use that thread in the meantime. So the total time was 30 seconds. The slowest was 15 seconds. Remember, it's only 4 seconds. That means that one thread, one request somewhere, or maybe more than one, had to sit there and wait almost 4 times almost, right? 3 times more than 3 times longer than it should have taken for their chance to get a ride on the thread. So the fastest was 4 seconds, which makes sense. It's 4 seconds plus the network overhead. It's both. Yeah, that's about right. The average, 7.8. Not great. Almost twice as bad, right? Now let's turn on virtual threads. With, okay? And where's my virtual threads? Enabled equals true. Reload. Go here. Refresh. Do-do-do-do. Boop-boop-a-doo-do-do. All right, so that felt faster. Not much, but a bit. Okay, go back here. Paste. All right, so 15 seconds. total to do the same amount of work, right? Versus 30 seconds over here. So literally twice as fast to do all the work for free, right? I switched on a property. I didn't do any actual engineering here, right? And then how much was the average request? The average is 4.5, so slightly worse than 4 seconds, right? Compared to almost 8 seconds before. What's the slowest? 7.3. So that means that in the worst case, it's still about what it used to be as the average, right? And then request per second, almost 4, 3.7, whereas before, it was 1.9. So almost double. That's for free, friends. So what I recommend is you go to management and say, look, I've got an audacious idea to radically improve our scalability. It's going to require 2 weeks of dedicated concentration, and I'm not to be disturbed. And I suggest as added incentive that any money recouped from cloud infrastructure spend be deposited into my bank account. And then disappear. Go to the Bermuda. I don't know. Go to the Bahamas. Come back with a tan. If they ask why, it's the LED that you were working on, surely, right? And then just do that. Update to Java 21 and do that, and things will be great. Okay, so virtual threads, awesome sauce, right? Awesome sauce software. It's free. That's why I have no room for you in my life if you're still using Java 20. Don't do it, right? Java 21 or later. Okay, so I've got that. Now I want to get this thing to production. I want this thing to be as fast and scalable as possible. Friends, it's important to remember that Java is already really, really, really fast, right? How many of you have seen this? This is the 1BRC challenge. Did you see this? My friend Gunnar Morling earlier this year did a little bit of nerd sniping. He asked his fellow nerds, Java champions, Java people in the community, to process 1 billion rows of weather station telemetry data. How quickly could you write a Java program with nothing but stock standard Java and the JDK to load 1 billion rows of, city and the location and the weather statistics, and to analyze it and to produce the mean, median, max, whatever, right? And that's 1 billion rows, about 13 gigabytes of text. Well, pretty fast, I'll tell you that. Like you go down here. Awkward. Come on. Lots of people, hundreds of people submitted possible solutions, right? The fastest response is 1.5 seconds. You hit enter and it prints out the statistics. It's 1.5 seconds. And, you can see over here, 1.58, 1.6. Now, to be fair, my friends, these are all GraalVM, but there's still, look, the fourth one is OpenJDK, that's 1.8, right? 1.9. It's still super fast. So Java is already very, very fast. Let it not be forgotten. Java is an amazingly fast language. It's also very, very energy efficient, right? How many of you have seen this blog from 2018, before the COVID pandemic, or BC? This blog asked the question, which programming languages use the least electricity? And we have here languages. The most energy efficient is C. It's the most efficient for machines, not for people. Very important. Not for people. The second most energy efficient language is Rust. Zero cost abstractions. Quite nice. Good job. Well done. Good on ya. C++. Tui. Disgusting. Moving on. And then we got Ada. Nobody cares. And then Java. Java's in the top 5 most energy efficient languages. Well done. Right? And by the way, you know who's not in the top 5? Oh my goodness. Here's Go, Away. Here's JavaScript, TypeScript. I don't understand this one at all. I still don't understand. Look, TypeScript is like 4 or 5 times worse than JavaScript. I thought TypeScript was the more rigid, you should know where you stand with that language, right? It's got a type system. It should be faster, if anything, right? Here are these 2 disgusting languages, the least said about which, the better. Moving on. And then Ruby and JRuby. Friends, JRuby is Ruby implemented on the JVM. Ruby is Ruby implemented in C. And yet JRuby is almost a third more energy efficient than the C implementation. The JVM is boss sauce software. Never let anyone tear it asunder. But that said, it could be faster. So we're going to use GraalVM. You know that Spring has great support for GraalVM. So I'll go back to my command line here. After I've disabled all these initializations, yeah, I got that. Go to the console, Maven, skip tests, p native, compile. And we're going to let that run. And anybody who knows me knows that this is my least favorite part of the technology. Because as amazing as it is, it just takes a long time. And it reminds me of this amazing XKCD cartoon that posits that the #1 program excuse for legitimately slacking off is my code is compiling. I never understood this joke before. I thought this was for the C++ people. But here we are. It's a weird year, right? And now, I got really bored. I get really anxious waiting for things to finish. And eventually I start to hear elevator music in my head. I start to hum. I look out the window. I stare. I tap my feet. I do something. And the problem with these builds is that they take long enough that you can't just kind of get on with it and move. You get kicked out of the zone, out of the flow, right? So I end up getting very bored and my mind wanders and I start hearing music in my head. And I thought, gosh, wouldn't it be great if everyone could hear that elevator music? So I asked. I went to the Oracle team and I said, please play elevator music during the native image compilation. I said, I already hear elevator music in my head when I do these sometimes long-running compilations. I'd just like everybody else to hear it too. Thank you in advance, and I appreciate your amazing work. And I do, I really do. They're doing great stuff. I got another response. Please, can you make it this elevator music? I'm not going to play it for you, but it's great. I'd add that using beeps in general, not only for native image, helped me to reduce development time. Yeah, like a microwave. Ding, it's done, right? You know when it's done. It tells you. Why can't my multi-million line compiler? And then finally, I got this response. Thank you for your feature request, Josh. The problem with playing music is that in the compilation process, it's just fixing the symptoms, and we've been and are still working on the cause, making GraalVM more efficient in terms of time, memory, and CPU. And I got a great response. This is, by the way, from a GraalVM team member, Dr. Fabio Niepaus, another one of my favorite doctors with Doctor Who, Strange, Seuss, Subramaniam, Sire, Pollock, and Johnson. And he said, anyway, I have prototyped a Josh Long mode. So that's what this is. You'd run the compiler, you'd run native image, hello world, it would print out music brought to you by Josh Long, you'd hear the music, it's a picture, but don't stop that from letting you understand that there's music playing, and then you're wondering who did this for you, who did this to you, why are you hearing music, that would be printed out in my picture, now you know, you're happy, you got music, you're okay. This is a great feature, I'm sure it'll get added sometime soon. Anyway, where were we? Target, service, zoom, 1.36 seconds, and of course, here's the RAM, du minus HS, that's in, PS minus O RSS, resident set size, that's in kilobytes, so divide by 1,000, 129 megs for an application with AI, with modularity, with efficiency, with all that cool stuff, virtual threads and everything, ready to go in production, that takes far less RAM than one page in one Chrome tab anywhere. My friends, there's never been a better time to be a Java developer. I hope you agree. Who agrees? Amazing time to be a Java and Spring developer. Thank you for your time today, and I'll hand it over to our MC. Okay, and then back over here. Great job, Josh. If you have any questions, pass this around. Oh, here.
Do we have any questions for Josh? Come on, we got to have at least one.
They're
No?
just stupefied.
Oh, you must have just given them all the information they needed. They're ready to go home and
More
learn.
questions than they had before.
All right. Oh, we got one here.
Is the code set that you used available online somewhere? So
Is it what?
The code set that you
surely.
used.
Yeah. Sorry, great question. Is the code available online? And yes, this one. So if you want to know what not to do, probably don't copy my code, you know? Yeah.
All right. Any other questions? All right. Thanks, Josh.
Thanks, everybody. Thanks, Dan. Thanks, my friends.